There are multiple ways to solve a system. The most straightforward one is to solve by graphing. So the solution to a system of equations is where the graphs intersect. So if you can graph both equations and see where they intersect, then that will tell you the solution. So if we want to solve this system graphically, what we'll do is we'll graph each of these equations and then find where they meet. So this has a slope of 3 and a y-intercept of -9. So we'll go to -9 and go up 3, right 1, up 3, right 1, up 3, right 1, and that will give us our line. So this is our graph. The second one, y equals 7 minus x, might be easier to look at as y equals -x plus 7. It has a slope of -1 and a y-intercept of +7. So going up to a y coordinate of 7, that's our y-intercept, and then we'll use our slope of -1 to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. And you should see that there's a specific integer coordinate where the two lines meet, and that integer coordinate is at +4, +3. So what I'm saying is that when x is 4 and y is 3, then both equations are true at the same time. At this point, we've solved the equation. If you didn't believe it, you could just plug back in to say, okay, 3 times 4 minus 9 equals 12 minus 3, which is 3. And 7 minus 4 is 3. So that also works. Solving this graphically, well, we want to graph these two. I think it'll be easiest to get these into y equals mx plus b form first. So let's convert into slope-intercept form by solving for y. Remember, these are not like terms when you're solving for y, so this will be -4x plus 12. And when we divide by -6 here, we get y equals -4 divided by -6 is +2/3. +12 divided by -6 is -2. So our slope is 2/3, and our y-intercept is -2. Graphing this will be at -2, and then up 2, right 3, up 2, right 3, up 2, right 3. Now let's do the other equation. So this one, if we were to solve this, I would subtract 2x from both sides first. Again, 6 and 2x are not like terms, so I'll say that it's that, and then divide by 2 on both sides. So y equals -x plus 3. So there is our line. If you're confused on that, again, the slope is -1, the y-intercept is 3. Go back and revisit how to graph linear functions if this is confusing right now. So that is our line, and they cross at the point 3, 0. So when x is 3 and y is 0, you get 12. When x is 3 and y is 0, you get 6. So that works. So solving by graphing has two main concerns. It only works with two variables. We don't really worry about graphing in 3 dimensions in Algebra 1. The functions sometimes intersect outside the graphing window. So if you imagine that the x-coordinates and y-coordinates are very far from 0, then you might not see them. And then the functions sometimes intersect at non-integer coordinates. So if I go back and see, okay, let's pretend that this was a line and that was a line. Well, do you know that that's exactly 4.5, 7.5? It's probably not. In order to solve that system, the purple system that I just drew, you'd have to use a different method. So if you know how to graph equations, it will solve many of them for you, but you have to keep in mind these limitations and be ready to use a different method if necessary. Thanks.